factoring strategy to solve trigonometric identities, and this time we will take cubes to factor, right? And here we have an example where we are going to use sum of cubes formula to factor. I hope you remember what is a cube plus b cube is equal to. We can write this as a plus b times a square minus ab plus b square. So we are going to use this formula to factor and then prove the identity. We have cos to the power of 6x plus sine to the power of 6x equals to 1 minus 3 sine square x plus 3 sine to the power of 4x. Now we can write the left side as cos square x cubed. You see that? So we'll write this as sum of cubes, and the other factor as sine square x cubed. That is the left side. And now we can apply this formula and factor it. So we got a cube plus b cube can be written as a plus b. A is cos square x and b is sine square x. So we can write this as cos square x plus sine square x. That is our a and b, right? Times a square, that means square of cos square x, that be cos to the power of 4x, minus a times b, which is cos square x sine square x, and then square of sine square x, which is sine to the power of 4x. Now have a good look at what we want to prove left side to be as equal to. On the right side we have only the sine term, so it's a good idea to write the cos terms in terms of sines, right? So cos to the power of 4x can be treated as cos square x, so we can write this as 1 minus sine square x, right? Whole square, that is cos to the power of 4x. Now the next term is cos square x, we can write this as 1 minus sine square x times sine square x plus sine to the power of 4x, right? So what we have done at this stage is basically we wrote cos square x as equals to 1 minus sine square x. That is what we did, right? Cos to the power of 4 is, let me write, cos to the power of 4 is actually cos square x whole square, right? So that is the first term, right? So that is how we get this statement, and cos square x has been written as 1 minus sine square x. I hope that's absolutely clear. Now let me expand these terms, or I can do what I can do is I can take 1 minus sine square x common, right? And then I have 1 minus sine square x here also. So let me, or rather let's expand and then simplify. That's a better way to do it. So now I'm going to expand this. 1 minus sine square x whole square is 1 minus 2 times sine square x plus sine to the power of 4x. Now let's expand the second term, which is minus sine square x, and minus as minus becomes plus sine to the power of 4x. And we have one term with sine to the power of 4x already with us. Now let's combine all these terms. We get 1 from here. Minus 2 sine square x and minus sine square x gives us minus 3 sine square x. We get minus 3 sine square x. As far as cos 4x is concerned, we have 3 terms, 1, 2 and 3, all with positive signs. We get plus 3 sine to the power of 4x, and that is actually equals to our right side. So we have proved that it's a trigonometric identity where left side is equal to right side. Let's go through this once again. So the idea is to factor. So we started with a cube plus b cube. We wrote cos square cube plus sine square cube and applied the formula. As you know, cos square x plus sine square x is 1. So this is 1, and therefore 1 times anything is the factor itself. So we got cos to the power of 4x minus cos square x sine square x plus sine to the power of 4x. Now in this term, we wrote cos to the power of 4x as 1 minus sine square x whole square, and then we wrote cos square x as 1 minus sine square x times cos sine square x, and then simplify to get our result. I hope you appreciate how factoring helps to prove identities. Thank you.